Okay, in this video, we're going to add two methods to our linked bag class. The first is a method to remove a random element from the bag. So we had implemented a similar method with an array. We'll now implement it with a linked implementation. So what we want to do here is if we have 10 elements in our bag, we want to pick a random number, and let's say it's 4. We want to remove whatever is that fourth one in the chain. Okay, so the first thing I need to do is create that random number using my random class. And then I will remove the position. I will generate a random number using number of entries, right? Because if this is 10, for example, then we'll generate a random number somewhere between 0 and 9 inclusive. So I have 10 options of random numbers. And now what I need to do is there's no way for me to get the fourth element in my chain, not with any of the references that I have, or the methods that I have rather. So what I need to do is kind of cycle through and count, okay, I'm on the 0th element, I'm on the first element in the chain, the second, the third, and so on up into this position. So what I want to do is generate a local variable called current node and point it to first node. And then instead of iterating until current node equals null, because that would take me all the way to the end of the chain, I instead want to have a separate counter, and I just want to iterate while I is less than position, because that's how many times I want to go through my current gets current.next.next.next. So as long as that's the case, current node gets current node.next. So this will essentially advance current node forward this many times. And then I increment I so that I'm updating how many times I'm doing that loop. So when I exit this loop, current node will point to the fourth element in the chain, for example, or the 7th element in the chain, whatever my random number is. Okay. Now, what good does that do me? Well, if I know I'm at that node in the chain, I can look at my other methods. In particular, I have a get reference to method, and I also have this remove method. Now my remove method takes in what? It takes in a reference of type T. Now can I get at my reference of type T if I have a node reference? Well, I can, right? So what I can do is I can say T, the random data to remove is going to be current node dot data. And then what I can do is I can just remove the random data using my existing remove method and then return it. Okay, so that is the remove random method. And again, we're taking advantage of this idea about pointing a variable at the node and then advancing it along, only instead of advancing it all the way to the end of the chain like we've seen so far, we're only advancing it a certain number of positions. And then we're taking advantage of some of the existing methods like our existing remove method to take that random data off the chain. The last method we're going to add is an equals method, which, as we know, has this exact header because it's overridden from the object class. So the first thing we're going to do is we're going to make sure that object is an instance of our linked bag. And if it's not, we're going to return false. And then we're going to create a linked bag. We'll call it the other bag. And we will cast obj to that type. Again, if this general structure does not, if you're not sure about this, post questions about that because all of our equals methods are going to look similar to this. Okay, so what I want to do is I want to know if all of the elements in my chain are the same as each other. Okay, now we could define our equals method just like we did for array bag, meaning that we are just checking, we're going to kind of remove everything from one bag and see if all the contents are in the other bag because they are unordered. But just because I want to show you an example of iterating through the actual nodes, we're going to define that for our equals method, two linked bags are equal if and only if their contents are the same and in the same order. So note, this is different from how we implemented it in ArrayBag and is really only for an example of using linked nodes, okay? Really what should make two linked bags equal is really if they just contain the same thing, since that's how we've defined a bag. But I want to show this example, so we're just going to say this is how we've decided to make our equals method, okay? So the first thing we can do is we can first check to make sure that our number of entries is equal to the other bag dot number of entries, because if they don't have the same number of things in the bag, then I can already tell you they're not going to be equal. So we can check that right away. That's an easy check. But then what we want to do is we actually want to cycle through the linked chain of objects. So what we can do is we can get a current node, this bag is going to be first node, and we can get a current node for the other bag, which would be other bag dot first node. And then we can just cycle through, well, current node, this bag is not equal to null, and because they have the same number of elements in the bag, since we've already made this check, we can just iterate along using a check for one bag instead of both. If we wanted to be extra careful, and it's really not necessary, we could say, and current node other bag is not equal to null, but that's completely redundant. And then what we want to check is whether the data at that node is the same, right? So we can say the current data for this bag is current node this bag dot data, and the current data for the other bag is current node other bag dot data. And if all of a sudden we find a mismatch, if the current data for this bag is not equal to the current data for the other bag, then hey, return false. Because if we find one data that doesn't match, we're done. But if we don't exit out of the loop, so that means that they are equal, we can say, okay, well then current data this bag gets current data this bag dot next. And current data other bag gets current data other bag dot next. So this allows us to cycle through both chains in the same loop and check the data stored at each one. And if we get all the way out of this while loop and we haven't returned false, then we can go ahead and return true. Okay? Yes, and I need to do this. Sorry about that. Okay, and not current data this bag. Current node this bag, oh goodness, and current node other bag. That's what's being advanced, right? The data is of type T. Current node this bag and current node other bag are of type node. Goodness. Sloppy typing, my apologies. Okay? So there's an example of adding two methods to this class, removeRandom and equals. Again, the equals method, there's this little caveat here, but I wanted to show an example of being able to iterate through both chains, comparing the data at each step in the chain to making sure that it was the same.